Hello everyone, my name is Konstantin Lepeshenkov. I am currently involved as a cloud solution architect here at Microsoft Norway, but also I am coding a lot, especially when it comes to serverless. And today in this session I would like to talk to you about Azure Durable Entities. And more precisely, how we can combine Azure Durable Entities with Azure SignalR Service and React and MobX library and TypeScript to create rich and stateful serverless web apps with just a little bit of scaffolding code from my side. Just as a little bit of a historical context here, we all know that Azure Durable Entities is yet another implementation of that very well-known architectural paradigm known as virtual actors. And these virtual actors as a concept, this is pretty much well known and has been around for quite a while already, for decades to be precise. So it is just interesting to see how that ancient design pattern sort of experiences a rebirth or a renaissance in this new serverless world that we are in. So many new implementations appear, including these Azure Durable Entities. Because indeed, you might go serverless, but still in many cases you would need to model and implement some more or less lengthy and stateful processes or workflows in your applications. And that becomes more and more difficult in this serverless world, especially if you rely on, let's say, traditional object-oriented approaches for this, because like those class instances that you're going to use for this, they will become too ephemeral, too unreliable for doing this. And this is where virtual actors as a concept, as a pattern, and Azure Durable Entities as an implementation comes to rescue. Now, the great benefit of Azure Durable Entities is that since it is a part of Azure Functions platform, Durable Entities are also available to you from various different programming languages. You can implement them not necessarily in C#, but also, for example, in JavaScript or TypeScript. At the same time, we know that we can use TypeScript for building our client side in form of, for example, like a React-based single-page application. And all of that made me thinking, what if we somewhat combine these two approaches all together and make our TypeScript-based durable entities automatically propagated and to the client side and make them directly callable from there? And maybe we could even extend it a little bit more so that our durable entities state changes are also automatically propagated to the client side and make our client side, let's say, React-based markup being automatically re-rendered. So this was basically the idea, and I just wrote some code and implemented it in the form of a proof of concept, and this proof of concept is now available to you via this GitHub template repo, which I call Durable MVC. Just to be completely clear on this, this is just a proof of concept. It is not a library, it is not a package, and more importantly, unlike Azure Durable Functions and Azure Durable Entities, this is absolutely not a Microsoft product. Oh yes, and why I called it Durable MVC? Well, basically because it looks like MVC model view controller, except for that for the C part, the controller part is implemented in form of a durable entity. The M part, the model, appears as a durable entity's state, and the view, the V part, is implemented in form of a React JSX or TSX markup. This concludes the theoretical part of this session, and now we're going to be completely practical, and I'm going to show you how to use this GitHub template to build a simple demo single page application for creating and managing appointments or meetings. Now, before we move on, let me just briefly show you how the outcome of our efforts is going to look like. And here I have it already running on my dev box, and it looks pretty much like a typical React-based single page application. And once I manage to log in one way or another, I should be able to create these appointments. Let's say first I would like to meet with myself, or else we might be having some appointment with other people, like that. And once an appointment is created, it is supposed to either be accepted by everyone or be declined by someone. Once everybody accepts an appointment, it goes into this mutually accepted state. Once anybody declines it, it goes into this decline state. Just notice that all these browser tabs get all state changes automatically and almost in real time. You might be thinking that this happens by magic, but in fact it happens with the help of Azure SignalR Service. Now let's proceed with the actual coding. And the first step for us would be to somehow get this GitHub template by either cloning it or forking it, or maybe using this template button here. This is what I have already done, and this is how this code base looks like in its initial form. Now for this demo, I'm going to use my GitHub code space. You are, of course, absolutely free to choose and use whatever dev environment you prefer. But what we have here is not just one project, but two projects. And the very first one, the root one, is a typical Azure Functions project written in TypeScript with just a little bit of extra scaffolding in it. And another one appears in this UI subfolder, and it is a typical React-based single-page application written in TypeScript as well. So both of these projects are written in TypeScript. And at this point, this code base is already deployable to Azure, but to make it run on your dev box, we of course need to have this local.settings.json file, which I already created. We need to put some configuration in it. And first thing is that obviously we would need to have a storage account, and I'm going to use this great open source Azure storage emulator known as AzureIt, which I already have running here. And also we would need to have an Azure SignalR service and a connection string to it. I'm not going to show that connection string to you, just trust me, it is here, specified here. Just remember that when you are going to create that Azure SignalR service instance, make sure you set it to serverless mode like this. The rest of it is just SignalR hub name, which can be anything. Let's call it like that. Now notice that this UI project has a subfolder called /sse/shared. This is, as the name implies, this is where we should put all the code that is going to be shared by both of these projects. And in most cases, that is going to be our entities state defined here. So let's define our appointment entity state first. I'm just going to reuse the file that comes with the template by renaming it like this. And what we need to define in our appointment state is basically this. We define it as a class, and it is going to have a list of appointment participants. For each of the participants, we're going to store their current responses in form of this enum. It can be either pending or accepted or declined. And we're also going to store this overall status, appointment entity status. That is basically it about the entity state. And now we need to define our appointment entity class. So these entity class definitions go into this durable entities folder here, which already contains some sample code as well. I'm just going to rename it reuse it like that. And here is how an entity class definition looks like. Now, as of today, durable functions for JavaScript and TypeScript, they do not provide class-based syntax for durable entities yet. So I just took liberty to implement this class-based syntax myself, and this is how we define an entity class, by just inheriting from this durable entity base class, which takes our appointment state, our entity state, as a generic parameter like that. Now, instances of this appointment entity that we have defined here are going to be exposed to the clients, but most likely we wouldn't want them to be visible and accessible by everyone. So the very first important thing for us to define here is this visibility setting. And the most obvious option to set this visibility setting to for us would be to set it to the list of users, which basically means the list of appointment participants. If you're curious to see what other options are currently supported, then these are these ones. It could be either accessible by the owner only or by the list of users, or an entity can also be accessible by everyone. And now let's proceed with defining signal handlers, or in other words, methods for this entity. And we define them as simple class methods like this, and we're going to have two of them. The very first is the initialization method that just basically takes list of participants for this appointment, and another method is going to be a method for participants to provide their responses, whether they accept or discard these appointments. And now let's proceed with implementing these methods. Just note that these entity methods can also be async. We're just not going to need that functionality for this demo. And let's first implement this init method here, initialization method. What we're going to do here is, first, we would like to ensure that the appointment creator, or the owner of it, the person who created this particular instance, is being included in the list of participants just in case. And to make sure that this is in place, we are using this functionality provided by base class which comes in form of this state metadata property, which among others contains this owner property, which identifies the creator of this particular entity instance. Then we need to initialize the entity state, and note that the entity state itself comes in form of this property from base class as well. We just need to initialize it to some initial state, to initial value, and what we're doing is that we're just setting this map of participants and setting the initial responses to pending, and we also set the overall appointment entity status to pending as well. Now the final step here is to actually initialize that list of users who are allowed to see this entity instance or to access it. And we're again using this functionality provided by base class, and we're just setting it to the list of participants. It is that pretty much simple. Also note that we do not need to explicitly load or save this entity state anyhow. This is also being done by our base class for us. Not only it is being loading or saving this state to persistent storage, but also it makes sure that state changes, the changes in this object, are being properly propagated to the client. And now up to this respond method, and its implementation is also going to be very simple. It will look like this, and what we're doing here is obviously we need to save the response from this particular participant, and to identify that participant we're again using the functionality provided by base class, the user which is making this particular call is being mentioned in this calling user property here. The rest of it is just about taking care of the overall appointment status, this property. Once everybody has accepted, we're just setting it to accepted state. And once anybody has ever declined, we're moving it to declined state. It is, again, that much simple. The final piece of a puzzle would be for us to add this delete method to allow the clients to allow the users to delete their appointments once they're not needed anymore. And here we're also just using this base class method called destruct_onExit, which means that whenever this method is being executed, this entity instance is going to be deleted or destructed automatically for us. And that was basically it for the backend side of it. We just defined this appointment entity and added a couple of methods to it. And now let's move on to the client side, where the rest of the code is going to reside. And that rest of the code is going to reside in this app.txt file here. Let me just, again, quickly clean it up a bit and add some important imports. So what we need to define here first on the client side is the React app application state. And it is going to look like this. So we define it in form of a class, and the most important property in this class is going to be this appointments property, which is going to be an instance of this durable entity set class. And what it is going to constitute is basically what is known as observable collection. So this is going to be our observable collection of entities. For those who might not be familiar with the term observable, basically an observable object, an observable JavaScript object is just an object which is capable of notifying its subscribers or listeners or observers about any change that happens in its internal state, in the values of its internal properties or their sub-properties or anything like that. Similar it is for an observable collection, which will notify its subscribers about any change in its items once an item is being added or removed or modified, for example. In most cases, those observers or listeners are going to be our React visual components that are basically supposed to automatically re-render themselves once any change of this state ever happens. So, thanks to these observable collections or observable objects and their observers, React visual components that can respond to their changes, this is basically what allows us to build our client application according to that well-known MVVM design pattern model view model. And this is all became possible thanks to this beautiful MobX library, which we're going to extensively use for our demo app. Now what we need to do is to initialize this appointments property and the rest of it. And we are going to do that with a constructor like this. Basically what it does is that it marks the rest of this project, the rest of this object as observable, just because we also have some extra properties here which are needed by the UI markup. And then we also need to add some extra initialization to our durable entity set class here. We're doing this by calling this static setup method. What we need to do here is to allow the user to somehow identify themselves. We're doing this here by implementing this fake username promise. Like this, we're basically just asking the user to enter their name, and this is it. It is intentionally called fake username promise just to underscore the fact that this approach is only supposed to be used for demo purposes. Obviously, in real situations, you would need to identify or authenticate your users in one way or another, and this durable entity set class also supports those scenarios as well. But for this demo setup, we're just going to stick up with the most simple option. And we also need to initialize this appointment property with an instance of a durable entity set class. And notice that it also takes our appointment state class as a generic parameter and our appointment entity as the name of it as a simple parameter. Oh yes, and of course we would need to create an instance of that client app state class like this here, and the rest of it is going to be pure markup, which is going to be the biggest part of this code, so I will just copy it. First we would need to add some dependencies. I'm going to use Material UI as the visual component library here, and also some CSS to be added. And here goes the final markup. There it is, like that. Now, let me just briefly start the build process, and while it goes, I will quickly explain how this React component works. So what we have here is this typical React visual component, and it has this create new appointment method, which is responsible for creating new appointments. And this is how we are making calls to our backend side entity instances. We are utilizing this call entity method here, which takes an entity ID, which is supposed to be somewhat unique. Therefore, we are making it look like a more or less unique string here. And the method also takes the entity method name and a list of parameters. For this purpose, we only have this list of participants. For this method, we have this list of participants to send, and this is basically it. The rest of it is a markup code which contains all these buttons for creating new appointments, like this. And also this is how we render those list of appointments that we have up to this moment, like that. We're just rendering them as a typical array of items. So what this rendering code contains is some code for rendering the appointment itself and providing some buttons for accepting or declining those appointment instances. And this is basically the rest of it. So the build process has succeeded, so let's just try to start it and see whether it works. Yeah, seems to work. Let's proceed and let's log in under some name, like that. And yeah, this is how it looks. And let's try to create some appointments again. Maybe for myself. Yes, here it is. And maybe for another person, and let's say I decline that appointment, and here it goes into decline state. Perfect, that works. So yes, we've just created this simple demo appointment management app by leveraging the power of Azure Durable Entities, Azure SignalR Services, React, TypeScript, and with just a little bit of help from this durable MVC GitHub template, You can always find this sample code as well as some other samples in this separate samples repo, and I will be always happy to chat with you, for example, via Twitter. I would be very grateful for any kind of feedback and especially for any kind of contribution to this project. Thanks for watching, stay serverless and take care.